Let's start today's topic. Today's topic is effect of dielectric permittivity of the solvent. Yesterday in the topic we discussed the effect of the solvent and the hydrostatic pressure on the rate of the chemical reaction in the solution form. And today the focus is on the dielectric permittivity of the solvent. Dielectric permittivity matters when the solution particles mean reactants are dipped in the solution form or dipped in any solvent that is acting as a medium, and that medium provides somewhat dielectric permittivity. So the mathematical derivation between the dielectric constant and the rate constant can be determined with the help of this equation. This equation helps us to determine the rate between the rate constant of the chemical reaction and the process by which the dielectric permittivity is controlling to it. K2 is equal to Kb T over H E minus delta F over RT. Kb over H is the rate constant, we have discussed it, and T is the absolute temperature, E is exponential, and when we take the natural log on both sides, we obtain the equation in this form. As you know that the natural log of exponential form is equal to 1, so the power becomes in the form of the normal value that you can see here. And when we take the 1 over RT as outside and put the value of delta R, delta F, that is the free energy of activation energy that is required to overcome before converting into the product. As you know that in the case of the reaction, only that effective collisions will result in the formation of the product that have the activation energy, means that the energy higher than the average energy. So we come to know that the activation energies or that must be made up or combinedly formed by the Coulombic and non-Coulombic activation energies. So according to the Coulomb's law, the force of activation or the force of attraction between the two charges, the force of attraction between the two charges is represented by the ZA and ZB. Here the ZA and ZB represent the charges on the particle AB that are here as the reactant, and the R is the distance between these two particles. You can say that it is a separation, it is a distance, and 4 pi epsilon naught is the permittivity of the free space. As the Coulomb talk about the two particles that are reacting or are being attractive towards each other in the free space or in the vacuum, so we were talking about the reaction taking place in the solution. So it means that we have to take somewhat different or additional constant that is considered as relative permittivity constant, and we can show it with the epsilon naught R. We will show it in the next page. So the next page is visible here. You can say that the Coulomb's law equation look like this, where it says that the force of attraction between the two particles immersed in a solvent, you can say the particle name is A and B, and the dielectric constant of that solvent is 4 pi epsilon naught. There the R square is the distance or the separation between these two charged particles, and epsilon naught, that is the additional constant, is the relative permittivity of the solvent, because we are taking the Coulomb's law to be applied in the solvent phase, not in the general gaseous form or in the vacuum form. So let's talk about the Coulomb's interaction energy. Coulombic interaction energy. When we talk about the Coulombic interaction energy, we will come to know that we can find this type of the energy by reacting the force with the separation or with the distance between the two charged particles. You can see that here the Coulombic interaction energy is equal to Fr is equal to simple generally the same equation that is coming down. Okay, and if we want to determine the Coulombic activation energy, means the energy which is required to carry on the process of the chemical reaction to be converted into the product, it means that there is need to multiply the interaction energy with the Avogadro's number that shows the total number of the molecules available on the both sides. The equation becomes in this way. So let's talk about when we will put the different values and how the equation will help us to demonstrate different factors in different ways. Putting the value of delta F that is obtained in this equation, that is about the Coulombic interaction energy. So we have not determined the factor delta F for the non-Coulombic factor, but we have determined the factor that is Coulombic. So let's talk about by putting this value in the equation. The equation that we have talked about previously. By putting the equation, the first one equation that was natural log K2 is equal to natural log KB T over H minus 1 over RT inside the bracket delta FC plus delta F NC that was representing to the non-Coulombic activation energies. So when we put the value of delta FC means that Coulombic activation energy, the equation appears in this form. As you know, in the given equation, this factor is multiplying with each other. It means that 1 over RT is multiplying once with this form and then it will multiply with the remaining form. So we can say after multiplying it will become like this. How it will become like this? Let me help you to understand this. For this understanding, we can say that this 1 over RT is going to react or it's going to multiply, in simple meaning, it's going to multiply with this ZA, ZB, E square N over NA over 4 pi epsilon naught R epsilon R. So it becomes in this form. As this factor is not multiplying with anyone else, so it will be taken as the normal. So now it's the turn of 1 over RT to be multiplied with this factor. So in this form, it will become like this. Because it is minus and it is plus. Because it is minus and it is plus. So it will become the minus. So it will become minus delta F and C divided by RT. So now let's talk about natural log K2 is equal to this form. How this has become in this form? Because when we arrange the equation that we have obtained in the above form, we will arrange it. We will take this factor in the front and this factor later on and this factor same at the last. Why we are doing and arranging this equation in this form? We are going to arrange this equation in this form because we want to determine the straight line equation graphs, the graphs intercept, slope, y, m, everything and x value. So we can say that it is a straight line equation where y is coming equal to natural log K2 mx here f1 over epsilon r, that is the relative permittivity of the medium. Here we are saying the medium is a solvent, m is the slope, and c, this whole factor is coming as the intercept. Okay, now let's talk about the remaining derivation part. It was that it is a straight line equation, and if we say that if the epsilon naught factor, the ER factor become infinity, means it approaches towards the infinity, in that case the K2 value is equal to this intercept value, because this whole factor will become infinity. So we will take only this part, we will consider only this part for the determination of the rate of the chemical reaction. So when we take this assumption in mind, the equation become in this form. Okay, now let's talk about our assumption where we were saying that this is a straight line equation. So in the sense of straight line equation, we said that natural log K2 is going to be equal to y. So we can draw a graph with the help of this equation where y is equal to natural log K2 and 1 over epsilon naught is the x, and the remaining factor was the slope. Here slope is called as m. So we can determine the non-Coulombic activation energy as well with the help of the remaining part of the equation. The remaining part of the equation, how it can help? The remaining part of the equation can help us to determine the intercept value, because we know that intercept is equal to natural log kbt over h minus delta f nc over rt. How this will define the different factors value? Let's come to understand. To understand this, we will talk about the intercept here. This intercept will help us to determine the non-Coulombic activation energy. Intercept will stay here and this negative factor go towards the left side and it become positive, and the remaining factor stayed at the left side in the same form, as you can see in the equation. So when we take the intercept on the other side, means that when we take this intercept on the left side, it become negative. So it become natural log kbt over h minus intercept. As you know that rt on the left side is dividing, so when it comes towards the right side, it start multiplying. So you can write this equation generally in this form. So this is how the non-Coulombic activation energy is measurable by taking the noun values and assumptions of the Coulombic activation energy with the help of Coulomb's law or Coulomb's equation for the two particles that are reacting in a solvent. So by the help of the Coulomb's law, non-Coulombic forces are also helped to be measured. This was all about the effect of the dielectric permittivity of the solvent on the rate of a chemical reaction. Thank you.